confirm it's order press 1, or if you would like to report this order press 2, talk to our customer support.
We'll be right back. Three minutes before class, and we got 4 people in there. Okay. Can you all hear me? And my, oh, there I am. Can you all hear me?
Yes.
Okay, thank you. So I do that for 2 reasons. One is to make sure the settings are right and for me speaking, and also so I can make sure the speakers are working for me to hear you. last period, they spent about 5 minutes trying to get my attention because I couldn't hear them. In Screen Pros. And very quickly. Here. Okay, we're at time. And there is more than 6 people in this class, so. It's a little upsetting. Let's see. Somebody hasn't signed in, so please sign in. Be sure you sign in. Okay, don't hesitate to get my attention by my screen. My screen has frozen. I seem to be having this issue with Zoom. In my 10 o'clock class, my screen froze twice. And yes, and in my 8 o'clock class, I think it froze once, maybe not at all. So Zoom likes to mess with me. Sometimes the screen freezes. Do not hesitate to speak. Unmute yourself and let me know. And also be aware of the fact that if my speaker settings decide to fritz out on me, sometimes that makes my screen freezing, sometimes makes the speaker not work. So I just have to keep a closer eye on the chat to make sure I see that. Be sure to pin my screen and sign into chat. Maximize the Zoom window. That does not mean to put it into full screen mode. that just means on the upper right-hand corner of the Zoom screen, you hit the square box and that maximizes it on your screen without getting rid of the chat bar. All right. I think this is where we left off last time. Talking about what a matrix is. Did we talk about what a augmented matrix was? Did we go into this? Can someone tell me? Did we cover this?
I didn't go into that.
Two people spoke at the same time. I didn't hear.
Actually, we left right there, but like I don't remember like everything. I just know that we left right there. Just
Right here?
Uh-huh.
Okay. That's what I thought. I just couldn't remember. All right, so to write these as augmented matrices, an augmented matrix is a matrix of a system of equations, and you want them written where you have x, y equals the constant. So, and here we have x. These aren't written correctly. The first one is, but the second two are not. So we would have to rewrite this before we do the augmented matrix. So the augmented matrix here is the coefficients and the constants. You always want it to be equal, the variable terms, the adding and subtracting of the variable terms equal to a constant. And so the coefficients of x and y, the coefficients of x and y, and what the two equations equal. This vertical line here makes this an augmented matrix because this is telling us that this is from a system of equations. Where the first column are the x's, the second column are the y's. So this is our augmented matrix. For letter B, well, we need to rewrite equations 2 and 3 so they're in the same form where they equal a constant, because here we have the constant on the left-hand side. We want the constant on the right-hand side. Sometimes that constant is 0, but in this case, the constant will not be 0. Okay. So we have to rearrange this so that now we have them equal to a constant by adding 4 to both sides on equation 2, adding 7 to both sides on equation 3. But notice in equation 2, we're missing the y term. Okay, so if we're missing the y term, that means we're adding 0. So that meant we're at 0 times y. In the third equation, we're missing the x. So that's going to be 0 times x. So the coefficient here for the x is 0. The coefficient here for the y is 0. So to write that in augmented form, we have the x's first, the y's second, and the z's third, and then the constant column. My first row will be 3, 1, -1, and 0. My second row will be 2, 0, 1, and 4. And then my third row will be 0, 1, 2, and 7. So they wrote it over here. So the first column is my x coefficients. The second column is my y coefficients. my third column is my Z coefficients, and the third column are the fourth column are my constants. And that's what the equations equal. The 0 in the coefficient portion of the matrix means that variable is missing. So Y is missing here and X is missing here. So that's how you write an augmented matrix. Now, whoa. Now here we can write the system of equations that go along with this augmented matrix. These are the coefficients of X, these are the coefficients of Y, and these are what the equations equal. So this is X minus 2Y equals 12, and this is 2X minus 6Y equals 18. So whether you're going from a system of equations to an augmented matrix or an augmented matrix to a system of equations, you want your variables to be in the same order in all the equations. And if they're missing a variable, then that coefficient is 0. So on this one, we have 3 equations with 3 unknowns. So we have 3 variables. So this is X, Y, and Z, X, Y, and Z, X, Y, and Z. The Y is, there's no Y term in this one, and there's no there's no X term in this one. Notice that the constant over here is 0. That happens. So writing this is 4x plus y minus 2z equals 6. And then the second equation is 3x minus 3z equals 10. Notice they put a gap here to show that the y term is not there. You do not have to do that, but they do this just to emphasize the fact that 0 means we don't have a y term. Just like the 0 in the first column of the third row, we don't have an x term here. Well, we have 2y plus z, 1z, and it equals 0. So that means 2y equals a negative z. Aha. Questions on this? Okay. Now we're going to be talking about the row operations. All right, we use augmented matrices to solve systems of equations, and we do that by using the row operations. The row operations are things we do to each row, either separately or in tandem with each other. All right, we can interchange any 2 rows. So like here, I can switch rows 1 and 2. Or I can switch rows 2 and 3, or rows 1 and 3. So that's just changing the order of the equations I'm writing. So it's not going to affect anything. They're just going to be in a different order. And so, but that's moving the entire row, not just part of it. If you move just part of it, then you're changing the problem. Replacing a row by a non-zero multiple of that row. So if I multiply a row by a number, let me go back here. I could divide the second row by 3, or multiply by 1/3. So that would be a 1, 0, -1, and 10/3. I don't want to have to deal with a fraction, but sometimes you have to. Okay. Oh man. So that's what they mean by replacing a row by a non-zero multiple of that row. Usually we're doing what I just did here, dividing so you get a 1 here. Or I could divide this row by 2 or multiply by 1/2 to get a 1 here. I could multiply this row by 1/4 to get a 1 here. Okay, we can replace a row by the sum of that row and a constant non-zero multiple of some other row. So coming back to what they're saying here is if I multiply row 3 by a -1, so I'm going to multiply each term in here by -1, so this becomes -3, that's say 0, that becomes +3, that's -10, and add it to row 1, and I replace row 1 with that result. So -3 + 4 is a 1, so this 4 becomes a 1. -1 times 0 is still 0, and 0 + 1 is still 1, so this 1 wouldn't go away. -1 times 3 is -3 is 3, and 3 plus -2 is 1, so this would become a 1. And then -1 times 10 is a -10, plus 6 is a -4. So my top row would become 1, 1, 1, -4. And I would leave the second row alone, even though I multiplied it by a negative number to add to the row above. And you can do that. Okay. And that's what they're talking about here. So we use these 3 methods to change what the matrix looks like, but not what the solution is. Not what X, Y, and Z equal, not what X and Y equal, to find the solution to the system. Okay. So their notation is different than my notation, only slightly. So what they're doing, they're going to multiply -2 times row 1 and add it to row 2 and put that back into row 2. So they do a -2 times 1, and we're going to add that to 2. They're going to do a -2 times a -4 and add that to a -6. They're going to do a -2 times 1 and add that to 8. Now, another procedural error that another procedural thing they do that is different than what I do. I find out what these values are first. So that gives me 0 here. So that means I'm going to replace this 2 with a 0. And then -2 times -4 is 8, and 8 plus a -6 is 2. So I'm going to replace this -6 with a 2. And then -2 times 1 is -2 plus 8 is 6. So this 8 gets replaced with 6. All right, and that's, so the row operation represents, it replaces the entries in row 2 with the entries attained by multiplying each entry in row 1 by -2 and adding the result to the corresponding entry in row 2. And that's what I show right here when I did this.
Sir, your camera froze.
Fuck them. Thank you. That's a simple fix on my end. It's just annoying. Where I stopped the video and I started back up again. Okay. So what they're saying here. What they're saying here, that with this statement here, with this expression here, which I do it this way. Sometimes it's, yeah, I have it. The arrow means I'm going to replace row 2 with the numbers I get. And these are the numbers I'm going to get. And they do the same thing, except they show it in a different manner. And so they're showing each thing I did here is what they're replacing this number by. So we're multiplying 1 by -2 and adding it to 2. So that's what's going to replace 2. What's going to replace 6 is multiplying -2 times -4 and then adding it to -6. So they're going to get the same numbers there. They just show it differently than I do it. So they got the 0, the 2, and the 6, just like I did. The only difference here is I would do my work for finding the new values for that row, and then I just write them into place. That's all. It's basically doing the same thing, except without having to write that matrix. So you're doing all this work, all the work here to replace row 2. Okay. Now, find a row operation that results. Having a 0 in row 1, column 2. Row 1. Oh, they want to get a 0 here. So that means I'm going to multiply row 2 by something and add it to row 1. So I'm going to multiply row 2 by something. So this 4 becomes 0. Well, if I multiply 1 times 4 and add it to -4, that does equal 0. So my row operation is going to be 4 times row 2, and I'm going to add that to row 1, and I'm going to put that back into row 1. So I have 4 times 0 plus 1 equals 1. So this 1 isn't going to change. This 4 becomes a 0, and then 4 times -2 plus 5. So now this 5 is going to become a -3 because we have -8 plus 5, which is a -3. And so the resulting matrix will be 1, -4, 5, no. 1, 0, -3. And the second row didn't change. Because we only used the second row to change the first row. We weren't changing it, but we were using it to change the first row. Okay. And so they have the same thing, only their notation is slightly different than mine. And again, they wrote what I was doing here in the positions they were winding up If you want to do it that way, then you're quite welcome to do so. If it helps you understand what you're doing there and making sure you're putting the numbers in the right place. This is shameful, but I make an ungodly number of mistakes when doing matrices. Because, especially in the classroom, because I'm in such a hurry to explain it, I'm not watching what I'm doing. Which is the big problem with matrices, is people, because a lot of it is tedious work, so things happen. And people don't do what they're supposed to. So they get the same matrix item because they did the exact same operations. Now, row echelon form, as a matter of fact, this is in row echelon form. Actually, the original matrix was in row echelon form. Row echelon form means you have a 1 in the first column, first row, first column is a 1, and everything below it is a 0. And then you move on down to the next row. And the first non-zero number is a 1, and zeros underneath it. And then you go to the next row down, and that number, the first non-zero number is a 1, and everything below it is a 0. So the larger the matrix, the more entries you have, then that's what they're talking about here. The words here aren't as explicit as things. So the entry in row 1, column 1 is a 1, and only zeros appear below it. The first non-zero in each row after that is a 1 with only zeros below it. And then the 1 appears to the right of the first non-zero entry in any row above. So what that looks like is you have a matrix 1, 2. And so I have 4. So I have 4. These are just any numbers. And here I have this over here. And so I'll have a 1 here and a 0, 0. And then I'll have numbers over here. And then I'll have a 1 underneath, it's a 0, and then numbers here and here, and then a 1 here and another number here. This is in row echelon form, where the main diagonal, I refer to this as the main diagonal, is nothing but 1s, and everything below the main diagonal is a 0. You can have zeros over here, that doesn't matter. What matters is for it to be in row echelon form. Underneath the main diagonal, you have nothing but zeros, and the main diagonal, it has nothing but 1s. I think that's an easier way of explaining what's happening here, is with a visual picture. Okay. So we want to solve this. That means we want to find the ordered triplet, because we have X, Y, and Z, so we have 3 numbers. So it's an ordered triplet, X, Y, Z. So to do that, we're going to use the row operations so we can convert this to row echelon form. Okay. So the first thing to do is to write this as an augmented matrix. And there we have it. All right. This is the coefficient is 1, so it's a 1, -2, 3, and 7. 1, -2, 3, and 7. Here we have 2, 1, 1, and 4. 2, 1, 1, and 4. And then -3, 2, -2, and -10. So -3, 2, -2, and 10. Now, once it's that way, the first thing we want to do is make sure we have a 1 in the first row, first column. We have a 1 in the first row, first column. So that's already done for us. All right, if equations 1 and 2 are reversed, then that's a simple matter of just rewriting it. So this one is in the first row and this one second row. Now, what they do in solving this is slightly different than what I do. It's confusing enough, but they try and do 2 rows at the same time. And I would do 1 row at a time. So use row operations to obtain a 1 and it's already there. And so now we move on to getting zeros below it. So we want the entries in column 1 below the row 1 to be zeros. And how they came up with and I would write, and I would do these separately. I wouldn't do this in one fell swoop. I would write this as a -2 times row 1 plus row 2, and I'm going to put that into row 2. So my notation is slightly different than theirs. And the interesting thing is, towards the end of this section, they switch to the row notation I use. Go figure. Okay, so what this means is I'm going to what makes this become 0 using this 1? So -2 plus 1, -2 times 1 plus 2. So I would do -2 times 1 plus 2, which is 0. And then -2 times -2 plus 1, which is a -3. No, not -3, that's 5. -2 times -2 is a +4. 4 plus 1 is 5. So this would become a 0. And this would become a 5. And then we have -2 times 3 plus 1, right? Because I'm changing this 1 by multiplying 3 by a -2 and then adding it to 1, which gives us, so -2 times 3 is a -6, -6 plus 1 is a -5. So this 1 becomes a -5. And then we do the same thing with the constants as well. So -2 times 7 plus 4. -2 times 7 is a -14. -14 and 4 is a -10. So this row here becomes 5, -5, -10. And that's I'm gonna go ahead and do it my way. And then I'll come back and we'll go through their one. A 1, -2, 3, and 7, 0, 5, -5, -10, and then -3 to -3 to -2, -10. And now I'm going to change the third row because I want this -3 to be a 0. And so what do I do to 1 to combine with -3 so it becomes a 0? Well, they tell you right here. I'm going to multiply row 1 by a 3 and add it to row 3 and put that into row 3. So that's going to be 3 times 1 plus a -3. And so then we have 3 times a -2 plus 2. And then we have 3 times 3 plus, what is that, -2? And then the last one is 3 times 7 plus a -10.
Excuse me, sir.
What?
The screen just freeze.
Okay. So now I'm changing this -3 to become 0. I'm changing this to become what? -6? Is that right? No. -4. And then I'm changing this. This positive to -2, I'm changing it to become a +7. And this -10 gets changed to a +11. So now my ending matrix is going to be 1, -2, 3, 7, the 0, 5, -5, -10, and then 0, -4, 7, and 11. All right, so they're doing these two steps in one. So I'm going to show you what that looks like, and I'm going to erase my middle matrix here because it's on top of it. So all that, my matrix over here is the same as this matrix here. I'm still wondering how I got the wrong answer last time. So that's how we changed all of those things to wind up over there. Now that I have zeros underneath this one, now I need to look at the second row, and where this 5 is, I need it to be 1. What's the easiest thing to make 5 become 1? What do I do to 5 so it can become 1?
You multiply by 5, I think.
Not multiply by 5, but multiply by what? Oh, they do it a little different than I do. That's right. That's right. They do it different than I do. Okay. So we have 1, -2, 3, and 7, and then 0, 5, -5, -10, and then we have 0, -4, 7, and 11. What I would do at this point, because what I noticed right away is that 5, -5, and 10 are multiples of 5. So if I multiply by 1/5, this 5 becomes a 1. This 5 becomes a -5. This 10 becomes a -2. And so that's what I get down. I'm going to write it down here. I get 1, -2, 3, and 7. The first row is going to stay the same for the rest of the way through. This becomes 0, 1, -1, and -2. And I haven't changed my last row yet. Now, the next thing I'm going to do is multiply row, because now I have a 1 in second row, second column. Now I want a 0 underneath it. Well, to make this become 0, if I multiply 1 times 4 and add it to the -4, that will give me 0. So then now that process is 4 times row 2 plus row 3, and I'm going to replace row 3 with the result. So multiplying 0 by any number is 0, and adding 0 to 0 is still 0. So I don't worry about these columns. I'm worrying about the rest. So I already did this one. So now I do this one is 4 times a negative 1, and I'm going to add that to 7, which is 3, because 4 times negative 1 is negative 3, and 3 plus negative 3 plus 7, oh, that's 4. No, that was right. 4 times a negative 1 is a negative 4, and negative 4 plus 7 is 3.
Sir, I can see the screen,
Damn. Okay. So 4 times negative 2 is 8, negative 8 plus 11 is 3. So my third row becomes 0, 0, 3, 3. So now I have 1, negative 2, 3, 7, and 0, 1, negative 1, negative 2, and I have 0, 0, 3, 3. Now I'm done with the second column. Now my third column needs a 1. So if I multiply row 3 by 1/3 and put that back into row 3, because 1/3 times 3 is 1, 1/3 times 3 is 1. So this becomes 1, negative 2, 3 and 7, and 0, 1, negative 1, negative 2, and 0, 0, 1, 1. Now I have it in row echelon form. Now that I have it in row echelon form, then I can rewrite this as the system of equations. So I'm going to come up here and erase this and put it up here. So now I have x minus 2y plus 3z equals 7, and I have y minus z equals a negative 2, and here I have z equals 1. And now I just do substitution. I know z is 1, so this one becomes y minus 1 equals a negative 2, or y equals 1. Am I doing this right? Because I think I'm getting a totally different answer than I did before. And now I put 1 in for y and 1 in for z. And so this becomes x minus 2 times 1 plus 3 times 1 equals 7. So x minus 2 plus 3 equals 7. Or I'm going to do that over here. X plus 1 equals 7, or x equals 6. And I know that's wrong. So my z is wrong.
excuse me, sir. The quality of your screen actually is pretty bad. I can see the board. I don't know. Can you try put it again? Or I don't know. Because
Oh,
Thanks.
hold on. Let's. What they did was they added this row to this row. They added row 2 to row 3 and put so 0 plus 0 is 0, and that's what they put here. 5 plus a -4 is 1, and that's what they put there. And -5 plus 7 is 2, and so that's what they put there. And then -10 plus 11 is 1, and that's what they put there. So my row here was wrong. Why is it wrong? Why is that wrong? Multiply by 5 over 5, 1 over 5. Gives me a 1, a -1, and a -2. So multiply by 4 and add. Multiply by 4 and add. Multiply by 4 and add. We're still going to get z as being 1. And so what they did here to get from here to here for this bottom row, they took the new row and multiplied it by 4 and added it to row 3. So they multiplied this by 4 and added it to 4 and got the 0. And then multiplied this by 4 and added it to 7 and got the 15. And they multiplied the 1 by 4 and added it to 11 and got 15. And now, since we're done here, they need to get a 1 here. And the easiest way to do that is to divide it by 15. So I'm going to divide the second row by 15 or multiply by 1 over 15. And so there we have it in row reduced. Now their row reduced is different than my row reduced. Why? It shouldn't be. This perplexes me. Okay. It should get the same answer. Divide by 5 is a 1. Divide by 5 is a -1. Divide by 5 is a -2. And then multiply by, so yeah, so we could still get 1 and 1 here. But this row should have been the same as this row. I'm not understanding why that's not working out right. The same. And so now we set it, we rewrite it as we write back as a system of equations, and they didn't fully do that. They didn't write it fully back as the system of equations like I did right here. They took z equal to 1 and took the second equation and put 1 in for z to find out what y is. And they got y to be -1 where I got it to be +1. Oh, no, that should have been a -1. Because we're adding 1 to both sides, that's a okay. So that was my mistake. Again, it's always my mistake. Okay. So now we have, instead of 2 times a negative times 1 is 2 times a negative 1. And so that gives me x plus 3 equals 7, or x plus 6 equals 7, or x equals 1. So my solution to the system is 1, negative 1, 1. Which is what they should get. And they got 2. Oh, because that's 2 times negative 1. That's not a 3. That's a 2. And so that's going to be a 5. Yeah, okay. I'm confusing the hell out of myself, not to mention what I'm doing to y'all. So there's a number of ways of writing the solution. One way is to stating x equals 2, y equals negative 1, z equals 1, or writing the ordered triplet, which is what I prefer. Does that mean you have to? It just makes it easier for me to grade. Now, the method for solving a system of linear equations, row echelon form, you write the augmented matrix, and then you use all row operations to get a 1 in the first row, first column. And then you use row operations to get all zeros below it. And then you repeat this process. And then the next column over, you want a 0 in that, and you want a 1 in that position and zeros below it. And once you get that accomplished, and then in the next row, the next column over, you need a 1 and zeros below it. You won't get a I don't know, will you? You might in the homeworks, but you won't in you won't for me. Only the most you'll get is 3 variables. Okay, so you okay, step 5 just means you keep doing it until the main diagonals has 1s and everything below it is 0s. And then the matrix that result is row echelon form. And so you put it back in as a system of equations and use substitution to find the remaining answers or the solutions. So this one, first thing I'm going to do is we have 1, 1, 1, 4. And then we have 2, 1, 0, 0, right? There's no z term, so its coefficient is a 0, and the constant is 0. And then we have 3, negative 1, negative 1, and 8. In the first row, first column, we already have a 1, so now I need to get zeros below it. So if I multiply 1 by a negative 2 and add it to 2, that will give me a 0. So my row operations here is I'm going to multiply 2 times row 1 and add it to row 2 and replace row 2 with those new numbers. So I'm going to do negative 2 times 1 plus 1, which is a negative 1. And then negative 2 times 1 plus 0, which is a -1 again, and then -2 times 4 plus 0, wait a minute, yeah, plus 0 again equals a -8. 2 times -4 is -8, -8 plus 0 is -8. So now my new matrix is 1, 1, 1, 4. And my second row is now 0, -1, -1, -8. And my third row I haven't changed yet. So it's 3, -1, -1, 8. Questions here? Did I do my arithmetic correctly? That's usually where I screw up. And then the transcription is sometimes where I screw up as well. Now I need a 3 here. I need where this 3 is, I need a 0. And so that's going to be a -3, and I use row 1 to have that happen. So -1, -3 times 1 plus 3 gives me the 0.
Excuse me, sir. It doesn't work. Just freeze again.
Damn it.
I think it's me. I don't know if it's me or just freeze.
No, it did.
Thanks, sir.
So I'm going to multiply 1 by -3 and add it to 3, and that gives me 0, so I can replace this with 0. Sorry. So now I have 1, 1, 1, 4, and I have 0, -1, -1, -8. And so now this is a 0. And so now I'm going to do -3. Yeah, so my row operations is -3 times row 1 plus row 3, and I'm going to replace row 3 with those numbers. And so now I do -3 times 1, and I'm going to add it to -1, which gives me a -4. So I have a -4 here. -3 times 1 is 1, and -3, and -3 plus -1 is -4. And then I'm going to multiply this one. I'm going to get the same number. So this is a -4 also. But now I'm going to do a -3 times 8 and add it to 8. No, -3 times 4, excuse me. So -3 times 4 is a -12. -12 plus 8 is a -4 again. So now we have another -4. Did I do that right? No, -4 times 4. No, it's -3. Yeah, that's right. -3 times 4 is -12. -12 plus 8 is -4. Just doesn't seem right. 3 times -1, 3 times -1, 3 times 1. Okay. Now that I have zeros in my first column underneath the first one. Now in second row, second column, I need a +1. So this is just going to multiply row 2 by negative. And so that's 1, 1, 1, 4. -0 of 0 is 0. Negative of -1 is 1. Negative of -1 is 1. Negative of -8 is 8. So this is 0, -4, -4, -4. That just seemed wrong to me. I copied, did I write down things correctly? -2 plus 2 is 0. -2 plus 1 is -1. Oh, this is supposed to be a 2 here. Right? -2 times 2, -2 times 1 is -2 plus 0 is -2. So that's a -2 here. Oh, yeah, so that means this here changes. So that's going to be times a -2, which is -6. -6 plus a -1 is -7. That doesn't seem right either. No, 3 times a -2 is 6. 6 plus a -1 is 5. So is this a 5? Did I do that right? I hope so. 9 was 4 times 8. 32. Nope, that's not right either. I did something wrong. God, I hate it when I do that. Did this one correct last time. Okay, so, well, I hit the wrong button. Okay, so the augmented matrix. So do I have the right augmented matrix? Yes, I do. And then they want, so they wound up over here. 1, -2, 2. Oh, they got 20 here. How'd they get 20? Because dum-dum, this is a -4 here, not a +4. So that's going to give us a 20 here. Okay. I'm on the right path. Okay. That's, yeah. Dropping a sign really screws things up. You know that? Okay. So now I'm going to multiply this row by 4 and add it to the second row. Wait a second. Oh, this was supposed to be 2 here. So I multiply by 4 and add it. So 4 times row 2 plus row 3, and I put that into row 3. Because 4 times 1 is 4, and 4 plus -4 is 0. And so my matrix is now going to be 1, 1, 1, -4. Don't drop that negative sign, Thomas. And then I have 0, 1, 2, 8. And then this stays 0. And 4 times 1 plus -4 is 0. 4 times 2 is 8. 8 plus -4 is 4. 4 times 8 is 16. No, 32. Whoops, I dropped that negative sign. Because 4 times -2 is a -8, -8, and 4 is 12, so that's going to be a -12 there. And 4 times 8 . Wait a second. So and that, yeah, because that's supposed to be a positive 8. And so now it's going to be a -8. And 4 times a -8 is -32, so that's going to be a -12 as well. But they got. So this will be a -12 and a -12. Wait a second. 4 times, oh yeah, so 4 times that is a positive. Because that's supposed to be a +2 there. I forgot to change that sign back again. And so that is a 4 here. Okay. Yeah. I get in a hurry and I make all these mistakes. So see what happens when you get in a hurry. And then the third row, all we need to do is multiply by 1/4 to get a 1 here. And that tells us what z is going to be. Z is a -3, and I put -3. So now I rewrite the 3 equations. And now I put -3 in for z to find out what y is. And then I put -3 in for z and whatever y is in for y to find out what x is. And they did it slightly different than I would have. They changed the first 2 equations this way. And they got x plus y equals -1 and y equals -2. And then they put -2 in for y to get x equals 1. And so the solution to this system is the ordered triplet 1, -2, and -3. All right, here's one with where we're going to have a dependent system. The others have been independent systems because each variable is not dependent upon another variable for existence. This one, we call it a dependent system because, as you will find out, 2 of the variables depend upon the third variable for existence. So you write it in standard in this form, and there are 2 ways of getting a 1 here. One is subtracting row 2 from row 1, or noticing that all 4 of these numbers are multiples of 3, so you multiply by 1/3, and it changes them appropriately. And now to get zeros here, and here, multiply this by a -2 and add it to the second row. So -2 times 1 is -2 plus 2 is 0. -2 times 1, -1 is a +2. 2 plus a -4 is a -2. So this will be a -2. And then -2 times 2 is a -4. -4 plus -4 is -8. So this -4 becomes a -8. -2 times 1 is -2. -2 plus 8 is 6. So so this 8 becomes a 6. And to get a 0 here, you multiply 1 by 8, and 8 plus -8 is 0. And so -1 times 8 is -8 plus 11 is 3. 8 times 2 is 16. 16 plus -4 is 12. And then, what was it? 8 times 8 is 8, so that makes this a -9. And that's what they did here. Okay. And so they got the same numbers I did. Oh, geez, I'm getting old. Now we're going to get a 1 here where this -2 is. So that means I'm going to multiply this entire row by -1/2, or I could do row 3 plus row 2. And that would give me a 1, that would give me a 4, and that would give me a -3. Well, just lo and behold, multiplying each one of these by 1/2, -1/2, gives me a 1, a 4, and a -3. Which is what they did. Okay. Now they changed. No, they didn't change this row, did they? Oh, yeah, they changed both of these two rows at the same time. That's right. Okay. And now to get 1 here is multiplying by 1/2. And now I want to get a 0 here. To get a 0 here, I multiply this row by a -3 and add it. -3 times 1 is -3. -3 plus 3 is 0. -3 times 4 is a -12. -12 plus 12 is 0. -3 times -3 is 9. 9 plus a -9 is 0. So what happens is my third row becomes nothing but zeros, which means we have a dependent system. If one row becomes nothing but zeros, then it's a dependent system. And that means you have an infinite number of solutions. And so so now we need to see what pattern do those infinite number of solutions come up in. If we had gotten all zeros here, but we had a different number, so suppose we had a 7 here, well, then that means they're saying 0 equals 7. Well, that's a false statement. That means that we would have no solution for this system. But this system means we have a dependent system, which means since we're dealing with 3 variables, so it's 3-dimensional space, so that's going to be a surface, a plane in the 3rd dimension. But it's a 2-dimensional space is the answer. Okay. So we rewrite these two. And this one just means Z is Z. Z is our independent variable, and X and Y are dependent variables, because X and Y depend upon what number we put in for Z. Yeah, it's in row echelon form because we have zeros down here, even though we don't have a 1 right there. And then they rewrote it. So we only needed the first 2 equations because everything else is zeros. And we solve this one for y. So that means you're going to subtract 4z from both sides. So y equals a negative 4z minus 3. So that's what the y value is. So right now we have that z is z, and y is a negative 4z minus 3. Now we need to find out what x is. So I'm going to replace this y here with this expression and simplify it and solve for x. So there they have it. So this becomes x minus a negative 4z minus 3. This minus sign here means I'm changing both of these signs in here. So that gives me x plus 4z plus 3 plus 2z. All right, I have 4z and I have 2z. So now this becomes x plus 6z plus 3 equals 1. And I subtract 6z from both sides, so that gives me the minus 6z on there. And then subtracting 3 from both sides, 1 minus 3 is a negative 2. And so that's what x is. So now I know x is a negative 6z minus 2. Now, what they say that the solution here is this, where z is a real number. So x and y depend upon what number we choose for z. Hence, we have a dependent system because x and y depend upon what z is for existence. Or you can write it as a triplet. Negative 6z minus 2 is the x value. Negative 4z minus 3 is the y value. And z is the z value. And then they have another way of writing it, which I don't use at all. So this way, where z can be any real number, where z is a real number. Okay. So I can change that ordered triplet depending upon what z is. Any values that will satisfy both those equations are solutions. So that means if you put 0 in for z, then that means y is going to be a negative 3 and x is going to be a negative 2, which is what they're saying here. And if I put 1 in for z, then negative 4 plus 3 is a negative 7, so that's what y is. I put 1 in for z here, I get a negative 8 for x, which is what they said over here. And if I put negative 1 in for z, so negative 6 times negative 1 is 6, 6 minus 2 is 4, so that's what they got for x. And then negative 4 times negative 1 is 4, and 4 minus 3 is 1. So depending upon what number you choose for z, you get numbers for x and y. Actually, I think this is a line. I have a calculator that used to be able to graph in 3 dimensions, but the screen is all screwed up on it. So, and that's a $200 calculator that I'm not going to replace. There are in fact infinitely many values of x and y for which the two equations are satisfied. Then the original system has an infinitely number of solutions, and we write the solutions of the original system as this, or as an ordered triplet. So here they're writing it in set builder notation. Here I just write it as the ordered triplet using the expressions appropriately for x, y, and z. So that's a dependent system. So these are the exact same rules that came up with before, but they're going to rename this. How we find the solution is what we were doing is what's called the Gaussian method. The Gaussian method. Okay. So to avoid making any more mistakes on the board, I'm just going to use theirs. And because now they're going to use the same notation I was using. Okay, so rewriting this as an augmented matrix. Now I need a 0 here. So that just means I do 1 minus 1. So I'm just going to do row 1 minus row 2, and replace row 2 with it. So 1 minus 1 is 1. 1 minus 1 is 0, so this becomes a 0. 1 minus a negative 1 is 1 plus 1, so this is going to be 2. And then 1 minus 5 is a negative 4. And negative 4 minus a negative 12 is negative 4 plus 12, so this is going to become 8, which is what they have here. And the first and second row, we haven't done anything to change those yet. Jeez. Okay. Now I need a 0 here where this 5 is. So I multiply 1 by a negative 5 and add it to 5. So that'll put a 0 here. So I'm going to do a negative 5 times 1. And so that's the process I'm going to do. I'm going to do negative 5 times row 1 and add it to row 3 and replace row 3 with those new numbers. So this 5 becomes a 0. 1 times negative 5 plus 1 is a negative 4. And this is going to be a negative 4. Negative 5 times negative 4 is 20. And 20 plus 0 is 20. So this row becomes 0, negative 4, 20. Right? Now that I have zeros underneath the first row, first column, I have a 1 there and zeros underneath it. Now in second row, second column, I need a 1. To make this become a 1, I multiply by 1/2. Easy. Divide each one of these by 2, the same as multiplying by 1/2. So I multiply each term in here by 1/2. So this stays 0, this becomes 1, this becomes negative 2, this becomes 4. And everything else in the matrix remains the same. Now, this is where a lot of mistakes happen, because people get in a hurry and want to write it down in a hurry, and so signs get changed and numbers get changed because transcription errors occur, or you can't read your own handwriting. That's my issue, or something like that. Now that I changed this 2 to a 1, now I need zeros under it. So I need this -4 to become 0. So if I multiply 1 by 4 and add it to -4, that makes it a 0. So that's what I do to the whole row. I multiply 0 times 0. I mean 0 times 4 and add it to 0. I add, I multiply 1 times 4 and add it to -4. I multiply -2 by 4 and add it to -4. That'll give me a -12 here. I add, I multiply 4 by 4, which is 16, and add 16 to 20, which is 36. So my third row becomes 0, 0, -12, 36. And the other two rows don't change. Right? When transcribing those rows, be very careful because signs can be dropped. Numbers can morph into different numbers. Or you could do my kind of thing. I'm writing down numbers, but I glance up somewhere else, and so I write that number down instead of the number I meant to be writing down. Okay. So now I have this matrix. My first two rows are fine. My third row, all I need to do is multiply by -1/12 or divide by -12. 0 divided by -12, 0. And so, so multiplying by -1/12. Dividing by a fraction is the same as multiplying by its reciprocal. Dividing by 12, well, multiplying by 1/12 is the same as dividing by 12. Yeah. So 0 stays 0 twice, and then -12 times a -1/12 is 1. So this -12 becomes 1, and -1/12 times 36 is a -36 divided by 12. 36 divided by 12 is 3. So this becomes a -3 because we're changing the sign by multiplying by a negative. Now it's in row echelon form. I know it's in row echelon form because I look at the main diagonal. I notice the main diagonal here is all ones and everything below it is zeros. So that's in row echelon form. So now I can rewrite this. I can rewrite this as a system of equations, so I can use back substitution to solve for X, Y, and Z. Well, I already know what Z is. Z is -3, right? Z is -3. And now we're going to use back substitution, and I like the graphics here on how they do this. So this, we rewrite it using -3 in place of Z to find out what Y is, and Y is -2. -2 times -3 is a positive 6. Subtracting 6 from both sides, you get Y is -2. And so now I'm going to put -2 in for Y and -3 in for Z. So this equation becomes this over here. So X plus a -2 plus a -3 equals a -4. Plus a negative is minus. Plus a negative is minus. So this becomes X minus 3, X minus 2 minus 3. -2 minus 3 is a -5. So X minus 5 is a -4. Adding 5 to both sides, I get X is 1. So X is 1. X is 1. Y is -2. Z is -3. This is my solution. So, oh yeah, I noticed this earlier. I haven't been able to get in there and change it yet. That should have been a comma. I don't know how it became a period. Questions? Yeah, we've gone through this kind of quick. Please ask questions. Do ask the instructor, ask me in class. Come to my office hours. Yeah, I unfortunately didn't observe my office hours yesterday, and someone missed out on my permanence because I was not there. So if that happens, please be sure and email me. Email me in ACES, because that's a quicker way to get a response out of me than through Canvas. And polynomial functions. Well, first thing I want to do here is talk about what a polynomial function is. I think that's all I'll do right now. Is what is a polynomial function? But we're graphing using transformations, which I don't. They only do this with x squared, and but graphing. There's other things we use here to do the graphing with, and so we'll deal with that. Identify the real zeros of polynomial functions and their multiplicity, and so those are things we do to graph. Okay, a polynomial function is in one variable is a function in this form. A sub n, the subscript here just means that this number here goes with x to the n power. So that's all it is. It tells me that this is the leading coefficient, this is the next coefficient, this is the second to last, this is the last coefficient of x, and then this is the constant. So the subscript here tells you what the degree of the x is. X is to that degree. So the a sub whatevers are the coefficients of the x's. N is a non-negative integer. So the exponents here have to be positive or zero. When the exponent is zero, you have the constant at the end, which is the y-intercept. Because if I put 0 in for x, all I get is a sub naught. I don't know why it's called like a sub. I call it a sub naught, and I learned it to say it that way instead of a sub 0. I don't know why. Anyway, so if a sub n is not 0, then it's called the leading coefficient, and if n is the degree of the and n is the degree of the polynomial. So whatever the largest exponent is, that's the degree of the polynomial. And that term with the largest exponent is the leading term, and that coefficient is the leading coefficient. The domain of any polynomial function is a set of all real numbers. The degree of polynomial functions is always, the domain of polynomial functions is always the set of real numbers. The range depends upon the degree of the function. If it's an odd degreed function, which is different than an odd function, an odd degreed function will have a range that is also all real numbers. where an even degree function, which is different than an even function. Even functions, even degree functions can be an even function, but not all even degree functions are even functions. Because it has to fit a certain definition for it to be an even function. All right, so even degree functions, you will have only a portion of the real numbers. It either starts at a number and goes to infinity, or comes up from negative infinity up to that number. It just depends upon which direction the function opens. Is it going to end up being concaved up or concave down? So that'll tell you. Let's see. So this, you look for the term that has the largest exponent. That exponent is 3, so this is a third degree function. The leading coefficient is 4. What else do they want? Is this in standard form?
Yes.
Yeah. So standard form, if we come back here, the exponents are in descending order. So when the exponents are in descending order, we say it's written in descending order. We don't say the exponents are written in descending order. We're saying the expression is written in descending order, and we understand that to mean by the exponents. So the exponents are in descending order. Notice there's not an x term in here. So that means its coefficient is 0. Okay. So the leading term is 4 is 4x cubed. And the constant term, well, boom, -7. Identifying the constant is the easiest part. From my point of view, it's the easiest thing to do is to identify the constant. It's the only term in there that has no variable. The leading term, determining the leading term is almost as easy. If it's written in standard form, it's the first term. If it's not written in standard form, then it's the term with the largest exponent. Keep the sign with the number. This -7 is plus a negative. This -7 is plus a -7. This -1/2 x squared is plus a -1/2 x. So the coefficient here of x squared is a -1/2. So you keep the sign with the number. That way you can rearrange everything and keep it correct. So P is a polynomial function in degree 3. It is in standard form. The leading term is 4x cubed, and the constant is -7. So on this one, is this in standard form?
No.
No, it's not. So how would you write that in standard form? Tell me what it would be.
-5x4 plus x plus 3.
Right. So that's standard form. The leading coefficient now is the first term, and the constant is the last term. Those things are important, especially when you start doing graphing. Okay. Is that in standard form? Is that a polynomial function?
No.
No. Because if I rewrite this using an exponent, this is extremely important. Because if I write this using an exponent, what's the exponent on x? Anybody remember?
1/3.
1/3. Is 1/3 a integer greater than 0?
No.
First of all, is it an integer? No. So this is not a polynomial function, so all the other stuff doesn't apply. But the constant is 0. Okay. This is not a polynomial function. It is a fraction. It's a rational function. We'll deal with that later. We deal with rational functions. So this is not a polynomial function because you have x in the denominator. And it doesn't divide out. Is a constant function a polynomial function? Everybody's afraid of getting this one wrong, right? Is a constant function a polynomial function? Well, I can write 9. I can write an x in here. I can say this is x to the 0 power, right? Because x to the 0 power is 1, and 1 times 9 is 9. So the degree is 0. Whoops. It has 0 degree. And that means the constant and the leading term are the same number. The leading coefficient and the constant are the same number, 9. This is a polynomial function. A non-zero constant polynomial function is of degree 0. The polynomial is in standard form. The leading term and the constant are both 9. This is important. Non-zero constant. If this was the 0 function, all right, so I'm gonna say q of x equals 0, or the function is the line y equals 0. This has no degree. Because when I multiply anything by 0, I get 0. So that means I could write 0 times x squared, or 0 times x to the 25th, or 0 times x to the 953rd. Is still going to be 0. So what's the degree? There is no degree. Because I can pick any number here to put as an exponent. So this is not a polynomial function. Well, kind of. It is kind of a polynomial function, but it has no degree.
Sir, it's already 1:43.
So I'll shut up now. So. It's not working for me. 1 second here. I think I did any saving. All right. We're done for the day. Oops. Hit the right button this time. So unless you have questions for me, you're free to stay. Otherwise, you're free to go. I hear people leaving already. Okay,
Bye, sir. Have a good weekend.
you too.
Thank you.
You take care. Hey, Pedro. I'm gonna turn my camera.
Sure, I was gonna ask you a question, but I can't hear you.